Hi friends, today we will see contrast stretching. Contrast stretching is a technique used to enhance the contrast of an image by expanding the range of intensity levels. It improves the visibility of details in images with poor contrast due to low lighting or improper exposure. In image there is already intensity levels, right? This contrast stretching will expand those intensity levels so that it improves the visibility of details in images. Images can be seen clearly. You already know in 8 bits grayscale image there are intensity values are 0 to 255. For example, sometimes due to poor lighting conditions, pixel intensities are compressed in a narrow range, making the image appear dull or washed out. Because of poor lighting conditions, pixel intensities are compressed, so it look like a dull or washed image. So this contrast stretching helps in redistributing these pixel intensity values to cover the full range image. Like it will enhance the image. For example, if you want to see the numerical, right, here is the image representing a pixel. They will give the values a equal to 3 and b equal to 5, c equal to 2 and d equal to 6. First we need to draw a graph. This a equal to 3 and b equal to 5 these are in x-axis, and c equal to 2 and d equal to 6 these are in y-axis. And this 3 comma 2 is 1 point and 5 comma 6 is 1 point, and finally 7 comma 7 is another point. So we will draw the graph 3 comma 2 1 point, 5 comma 6 1 point, and 7 comma some another point. We will draw the these lines connecting these points. First we will calculate this slope, and then this slope, and then this slope. We will call this slope as alpha, we will call this slope as beta, we will call it this slope as gamma. So we already know slope formula is y2 minus y1 by x2 minus x1. If we see alpha, y2 equal to 2, y2 equal to 2, y1 equal to 0, x2 equal to 3, x1 equal to 0. So 2 by 3 equal to 0.66. And beta equal to y2 equal to 6, y1 equal to 2, x2 equal to 5, x1 equal to 3, 6 minus 2 4, 5 minus 3 2, 4 by 2 2. Gamma equal to 7 minus 6 by 7 minus 5, that equal to 1 by 2, that equal to 0.5. So if you want to find the output image, right, formula is they have given the a equal to 3 and b equal to 5, right? So there are three different formulas for it. If the value input, this r is input image, whatever we are giving. If it is under 0 to 3, it formula is alpha into r. It is 3 less than or equal to r less than or equal less than 5, then it is beta into r minus a plus c. If it is 5 less than or equal to r less than or equal to 7, then formula is gamma into r minus b plus d. If you see here, these are r, these are s. These are our input image values, pixel intensity values. These are output image pixel intensity values we are calculating. So if r is 0, from this formula, if r is 0, alpha into r is 0. So alpha into 0, 0. Similarly, if r equal to 1, alpha into 1, alpha we have calculated right here, 0.66. So 0.66 into 1, that equal to 1. That equal to 0.66, and we will round off this value to nearest integer. So it is equal to 1. If r equal to 2, similarly alpha into 2, that equal to 1.32. We will round off it to 1. And if r equal to 3, this formula is beta into r minus a plus c. So beta into r equal to 3, a equal to 3, 3 minus 3 plus 2, that equal to 2. If r equal to 4, beta into 4 minus 3 plus 2. Beta we have calculated here, right, 2. So 2 into 4 minus 3 plus 2, that equal to 4. If r equal to 5, the formula is gamma into r minus b plus d. So gamma into 5 minus 5 plus 6, that equal to 6. And if r equal to 6, gamma into r minus b plus d. So 6 minus 5 plus 6, that equal to 6.5. We will round off this to 7. And if r equal to 7, gamma into 7 minus 5 plus 6, that equal to 7. So these are the input values, input intensity values. These are the output intensity values corresponding to this input intensity value. So our input image is this one. We have taken this image. This output image is this one. For example, for 1 we have calculated it as 1. For 5 it is 6. For 3 it is 2. For 4 it is 4. For 7 it is 7. For 3 it is 2. How we got this one, you know, right? If you see here, for 0 it is 0, for 1 it is 1, for 2 it is 1, for 3 it is 2, for 4 it is 4, for 5 it is 6, for 6 it is 7, for 7 it is 7. So by taking this one, we will calculate this input by using input 1. For 1 it is 1, for 5 it is 5, 6, for 5 it is 6, for 3 it is 2, for 4 it is 4. Similarly, we will calculate for all pixel intensity values. So this is the final output image. This is contrast etching. Next we will see about intensity level slicing. Intensity level slicing is technique used to highlight specific intensity ranges in an image while suppressing others. It is basically intensity level slicing. What it will do is they will give the values. So between these values we will highlight the whatever intensity ranges are there in between these two values. We will highlight those intensity levels and we will suppress the remaining all other intensity levels. Basically it is useful in applications like medical imaging where certain tissue structures need to be emphasized. So mainly it is used in medical imaging one. And there are two types in intensity level slicing. These are without background and with background. Without background means only the selected intensity range is highlighted and the rest is set to black. Like they will give the two values, right, a comma b. In these between two values we will highlight the intensity range values and remaining all values we will set to black. That means 0, we will set to 0. It is same as clipping. We have seen the clipping, right? If you don't know about clipping, you can see the previous video. We have discussed it there. What is clipping? It is same as clipping only. And second type is with background. The selected intensity range is highlighted while keeping the rest of the image unchanged. They will give these values, right? In between these values we will highlight the intensity ranges and remaining all the values we will image is unchanged, like it will remain same only. For example, here they given the a equal to 2 and b equal to 5. So formula is for output image, formula is s equal to we will set to 7. Here L equal to 8, right? Because highest value is 7. So 2 cube L equal to 8. So L minus 1 equal to 7. So in between 2 less than or equal to r less than or equal to 5, we will set to value as 7. For all other values, we will set as remaining same input image only. For example, if we see 1 here, 1 is out of this range, so we will keep as 1 only. 5 is in this range, we will keep it as 7. 3 is in this range, we will keep it as 7. 4 is in this range, we will keep it as 7. Similarly, all we will keep for every input pixel, we will calculate output pixel. For here 6, it is out of range, so we will keep it as 6 only. For 1, it is keep out of it range, we will keep it as 1 only. For 1, it is out of it range, we will keep it as 1. Remaining all are in the same range, so we will keep it as 7. For without background and with background difference is here. Otherwise, we will keep it as 0 in without background, and with background we will keep it as r. That's it. Like for example, all the 7 remaining are there, right? 1, 6, 1, 7. Here for without background we will keep it as 0. For with background we will keep it as remaining same, 1, 6, 1, 1. Yeah, that's it. That's it for today.